Students, in the last section, in the last video, we discussed about some of the physical quantities associated in kinematics, and the physical quantities like distance, displacement and speed. Today we will go for another physical quantity, that is the velocity. Today we will discuss about the velocity. So what is this velocity? So we can say that it is the rate of change of displacement. Velocity is the rate of change of displacement. Rate of change of displacement with respect to time. Rate means it is with respect to time. The rate of change of displacement with respect to time, that is called as the velocity. So I can write this velocity is equal to, mathematically you can write this is equal to displacement by time. We can write this displacement by time, that is the velocity. So as you know, displacement is a vector quantity, so the velocity is a vector quantity. We can say the velocity is a vector quantity. Velocity is a vector quantity. It means it has both magnitude and direction, but speed is a scalar quantity. So speed is a scalar quantity. So according to that, how we will relate this? Speed equal to distance by time. Distance by time. So I can define this velocity in terms of speed. So we can say that the velocity can also be defined as the speed of an object in a particular direction. Speed of an object in a particular direction. Speed of an object in a particular direction, isn't it? Why? Because the velocity gives you what? Speed, the magnitude part, and the direction combinedly, that is your velocity, right? So my speed in any random direction, you can say that is I can say speed. I can move, or I am moving with a speed of 5 km/h, but I can say that my velocity is 5 km/h towards north, means speed magnitude gives the speed magnitude. From the speed we got the magnitude, and the direction combinedly known as the velocity. Okay, and as this speed is a vector, so it can be positive, negative, 0. So it can be means the velocity can be positive, negative or 0. Velocity can be positive, negative, 0, because speed is a scalar quantity, so it is always positive, or if a body is at rest, then you can say the speed is 0. But while discussing about this one, about the velocity, then it can be positive, negative or 0, because it is a vector quantity. Okay, and as you know that the distance, if you relate again the speed and velocity, as you know, distance is always greater than equal to the magnitude of displacement, isn't it? Magnitude of displacement. I can write this magnitude as a more magnitude of displacement. So if distance magnitude is greater than the magnitude of this distance is greater than equal to the displacement, or the distance it is only the magnitude, then accordingly you can say the velocity is less than equal to, because displacement is the velocity and the magnitude of the velocity is less than equal to the speed, that we can also define. Okay, so this is the about the velocity. Then as you know, the unit part in SI or in any case we can say meter per second, meter for displacement and second for time. And in CGS we can define this as a centimeter per second, and commonly we are using this as a also kilometer per hour. Long speed can be a large value of speed can be expressed as a kilometer per hour. Clear? So this about the velocity, some of characteristics of this velocity. Now next we will go for the velocity can be like your speed can be a variable or uniform speed. Similarly, the velocity can be a uniform velocity, or we can say the variable or non-uniform velocity. Like that, we will define some of the terms of the velocity. Yes. Now we will go for the uniform velocity. So what is this uniform velocity? Uniform velocity. The velocity of a body is said to be uniform velocity, okay, or a body is said to be in uniform velocity if it covers equal displacement in equal intervals of time. Covers equal displacement in equal intervals of time. Means equal displacement means the body should be equal displacement, means it is a vector quantity. So okay, so let me take an example like this. Suppose a body starts from O, reach at A, and the displacement here is x1 with a vector, and the time interval is t1, right? So t, suppose the time is t, then it's reached to the point B. Again the displacement is A to B is x1 in the same time interval t. So suppose I am moving in a particular direction. So in a straight line, the simple thing is that you can say that simple example is I am moving in a straight line. I covers 5 km in 1 hour. In the same direction, again 1 hour, I find I cover 10 km. Next 5 means total is 10 km. I start from here, I covers in 1 hour 5 km, then next 1 hour 5 km, next 1 hour 5 km, like that. So in the same particular direction I am moving, so you can say that it is a uniform velocity. Is that clear? So uniform velocity means, are you clear, that covers equal displacement in equal intervals of time, and in addition to that, however small these time intervals will. It is not necessarily for 1 hour I am covering the distance also. You can say that for 1 second also. Yes, for 1 second also I am moving in this direction. In every 1 second, if my displacement is same, then that is also a uniform velocity. So we can add here also, while writing you can write that however small these time intervals may be. So I can add here also, however small these time intervals may be. However small these time intervals may be. This is called as the uniform velocity. Then comes your variable velocity. Variable velocity. Like your variable speed. So these definitions here, when you come from speed to displacement, you are moving from only magnitude part to magnitude and direction part. That's the difference. So variable velocity means what? When we will say that the velocity is variable, a body is said to be moving with variable velocity. Okay, you can note like this also. A body is said to be in variable velocity if either its speed changes, means either the distance traveled with respect to time changes, or either the speed changes, or you can say, or the direction of motion changes, because velocity combines two things, speed with the direction, that is the velocity. So either the speed changes means the magnitude changes or the direction changes, then that speed is called, the velocity is called variable velocity. So the motion of a body is said to be a variable velocity, or the body is said to be moving with variable velocity if it covers, I can say in other words, if it covers equal displacement means distance and direction, equal displacement in unequal intervals of time, or unequal displacement. Unequal displacement means either magnitude changes or direction changes. So this is unequal displacement. Suppose this is 5 meter from here to this point. This is one displacement. But if the body is moving like this for 5 meter, then in both the cases the displacement is different. Magnitude is same, distance covered is same, but direction is different. So unequal displacement, it covers two parts. Okay? Try to understand, try to know about these things. So unequal displacement in equal intervals of time. Isn't it? So that is called as your variable velocity. Okay? Then the body is in a variable velocity. So in that case, what happens here? Now the body has covers unequal displacement in equal intervals of time. Okay? Suppose I start from here, go in a straight line. Think that is I am moving in a straight line. So I covers 5 kilometer in 1 hour, first 1 hour. Next 3 kilometer in the same particular direction. I covers 3 kilometers in next 1 hour. Then again I covers 7 kilometer in the next 1 hour. So when you find the total displacement I cover in 3 intervals in 1 hour, 1 hour, 1 hour. So in this part I find that the body is in a variable velocity. Means I am in a variable velocity. So when there is a variable velocity, so it is very easy or very simple method. We can, when a body is in the variable velocity, we can say how can we find the average velocity. We can calculate the average velocity. Okay, let me write this average velocity. Okay, let me erase this. Now let us come to the average velocity. So what is this average velocity? So the average velocity, we can say that when a body is in a variable velocity, then the average velocity of the body is the ratio of total displacement to the total time taken. Ratio of the total displacement to the total time interval, or you can say the total time interval, in which, or total time interval, we can make total time interval in which the displacement, the total displacement, with the displacement we have written, ratio of the total displacement to the total time interval in which the displacement occurs, or the displacement covers. Clear? So we can write this as the, let us consider this is the origin. From the origin a body travels like this from the origin. Let at the point A it has a displacement of x1 in time t1 from the origin. Then at the point B it is the displacement of x2 with respect to the origin. I am finding this x2, means this is total is x2, this is x1. So I can show like this. This is x1, this displacement along this direction the body is moving. So it is a direction part. So I can show x1. Then it covers x2 in this direction. Means from here, not from this, from the origin. Clear? So this is x2 from the origin. It covers this point B. So here at B the time is t2. Then if I will ask you what is this average velocity, then V average velocity is equal to the total displacement by total time interval to cover this displacement. So what is the total displacement? From O to AB the total displacement is x2, from O to A x1. So in this time interval AB I am finding out it is t is equal to suppose 0. So here t is equal to t1, here t is equal to t2. So in this time interval I am finding what is the average velocity. In this path, when it moves from A to B, it covers, it may be 1 hour, it may be 5 hours. So 1 to 5 hours, 4 hours. In these 4 hours, it may have a variable velocity. Means it is covers unequal displacement. In this displacement, it covers unequal displacement in equal intervals of time, or it covers equal displacement in unequal intervals of time in this time interval. So in that case, when I find this average velocity, I can write this is equal to x2 minus x1. That is the total displacement. Yes or no? x2 minus x1 divided by t2 minus t1, or that can be written as delta x by delta t. That is the average velocity. That is the delta x, that is the distance, the total displacement in the time interval delta t. So this is called as your average velocity. When this average velocity comes, then if I ask you what is the velocity at this particular instant, at this particular point, what is this velocity? Because you have told me that in this 4 hours interval, you told me this is the average velocity, but the body is not moving with a constant or a uniform velocity throughout this A to B, throughout this A to B. So in that case, if I ask you what is that particular, means suppose the body starts from here in the morning. In the morning you start from here. Okay. Now you go for your, or from your home you start in the morning at 6 a.m. You goes to the market. Suppose you have started your journey to go to the market. So at 6 you start and you reach at the market, suppose at 9. So you start here from 6 a.m. you reach to the market at 9 a.m. But in between there is your friend's home, there you reach here at 7 a.m. and you rest here for 2 hours. You rest here for 1 hour, then you start from here. So at 6 a.m. you start, so this, I will consider this is time is 0 suppose. So you cover first in 1 hour, you cover your friend's home. So suppose this distance is suppose your 2 kilometer. 2 kilometer. After covering 2 kilometers in 1 hour, you meet with your friend, and then after that you go for the market. Then you reach at the market at 9 a.m. So in this 2 hour, here it is 1 hour, you covers 2 kilometer. But in this 2 hour, suppose you covers, this is your, from your friend's home, the market is at 7 kilometer. So in this 2 hour, you cover 7 kilometer. So in this 2 hours, is this your, in this covering this A to B, how much you are covered from O to A, this displacement, in what time? Are you covering the same thing? No. In 2 hours, you are covering 7 kilometers. So in this direction from A to B, what is your velocity? 7 by 2. But here what? 2 by 1. 2 kilometer per hour. It is 7 by 2 kilometer per hour. So you have a what? Variable speed. So in that case, if I will ask you what is the average velocity in this time interval, so this will be 7, total kilometer is 7, sorry, this is 9 kilometer minus 2 kilometer means this is 7 kilometer divided by 2. This is your average velocity. This is your average velocity, isn't it? So but from the origin it is 9 kilometer. So this is x2 is 9 minus x1, x1 is 7, so 9 minus 7 by t2 minus t1. So that is a 9, it is 9 am, it is 6 am, so this is by 3 hours. Okay. Accordingly you can find for the total path. Okay. Now in this case, when I will ask you during this travel from your home, from your friend's home to the market, you start from here 7 am, you reach here 9 am. So your speed is not, so it is the marketplace, you have some homes, some breaks, some crowd place like that. So your velocity is changing, your direction is also changing, so accordingly your velocity also changes. So if I ask you at 8:10, at a particularly 8:10 am, what was your speed? In that case what I will do? I will make this total 2 hour smaller and smaller. Suppose this place at this point, suppose I am at 8, 10. At 8, 10, I am at this place. So to get that point, what I have to make? This 2 hours should be reduced and becomes smaller and smaller. So to get the instantaneous velocity, what I will make? Time should be smaller and smaller, so that your displacement becomes smaller and smaller. Because when you make this 8, 10 very close, but that is a point, at a particular point, 8, 10 m. At that point, what is my velocity? Means what is the displacement at this time? That displacement by the time. That will give you the instantaneous velocity. So to get this instantaneous velocity, let me write this. Instantaneous velocity means the velocity of the body at a particular instant of time, or at a particular point, or at a particular position. Okay. So next is your instantaneous velocity. If I say instantaneous velocity. Okay, what is this instantaneous velocity? The instantaneous velocity of a body is, okay, for a body is what? Is the velocity at a particular instant of time or at a particular point. The velocity at a particular instant, velocity at a particular instant or at a particular instant or at a particular position. At a particular position. Okay, so this will give you the at a particular position or at a particular point, what is its velocity? That is called as the instantaneous, okay, instantaneous velocity, isn't it? So in this instantaneous velocity, when you calculate this instantaneous velocity, how we will find? From that average. I am making the time smaller and smaller, so I can write this instantaneous velocity like this, and it is a vector. V instantaneous means velocity with vector symbol. Limit, I am making the time smaller and smaller, tends to 0. The displacement delta x by delta t. Delta x by delta t. Clear? So we can write this is equal to delta x by delta t. So obviously this is the vector, right? Then this is equal to displacement. We can write this is equal to what? Smaller and smaller means we can show that is a dx by dt. So this is the formula for instantaneous velocity. So you can say that the instantaneous velocity v is equal to dx by dt. So from here also you can know another thing is that, suppose here I will ask you from here, what is dx? Dx is equal to, suppose you take the magnitude of this. So what is this implies? Magnitude of this instantaneous velocity. That is what? D, speed, instantaneous speed. You are considering the magnitude. So this is equal to your dx by dt. So from here also you can find what is the displacement or distance, because when you take the magnitude it becomes a distance. We will not say that it is a displacement. So this implies dx is equal to v dt. Dx is equal to v dt. So v into dt, that will give you the distance traveled in the time interval dt if the body has an instantaneous velocity v at that instant dt. At that instant dt, very small instant time of dt, what is the distance? So this is equal to dx equal to v dt. Got it? Okay. So now in that part, so sometimes it is the question, suppose I will ask you what is the distance travelled by the body from the position x1 to x2, then we will do integration. That is the use of integration. What we read that we use here. So we will write dx with limits body x1 to x2. That I will find the distance. That equal to, suppose I know the speed, because I am considering the magnitude. If your velocity is there, then you put the velocity and direction part is also there. You can take this direction also. So dx is equal to v dt and at x1 suppose the time is given here what is variable, this dt, the time is very smaller time, so time is changing, so we can take t will be given as t1 to suppose t2, so we put the limits like this. So this is the definite integral. When you put that, you will get what is the distance traveled by the body when it moves from position x1 to x2, if we know a small distance traveled in a small time dt, and at x1 the time is t1, at x2 the time is t2. So this is the use of the integration. Clear? So we will use that in later stage. So for the time being, you understand this thing, what is that instantaneous velocity. Okay. So now I will ask you a question, that if I will ask you, if a body is moving in a straight line, if a body is moving in a straight line and in the same direction, in a straight line, it is moving in the straight line and the same direction. So in that case, what is the average speed and what is the average velocity? What is the average velocity? Are they same or different? You think that, you think about this. When, or the question may be, when is the average speed of an object equal to the magnitude of its average velocity? Means obviously magnitude of the average velocity. So average speed and average velocity, if you calculate, if the body is moving in a straight line in a particular direction, then it is not in a particular direction, the distance is equal to displacement. So speed is equal to the magnitude of the velocity. Okay. So if a body is moving in a straight line, then in a straight line path, then its average speed is equal to average velocity, because in a straight line the distance is equal to displacement. Clear? So this is about the velocity part. Then generally we will use a term called as a uniform velocity. All these things we read that. Generally in a kinematics we will use the term as we can say uniform motion. We will use the term as uniform motion. We use this term uniform motion. So what is this uniform motion? When you say that a body is in uniform motion, right? An object is said to be in uniform motion if it covers equal distances in equal intervals of time. In equal intervals of time, it covers the equal distances, and remember one thing, however small these time intervals may be, in a particular direction, Clear? You can note this one. Is that clear? Uniform motion. The motion of a body is said to be uniform motion if it covers equal distance in equal intervals of time, however small these intervals may be, it is not necessarily we will measure 1 hour, 5 hours, 7 hours, it may be 1 second or 1/10 of a second or 1/100 of a second, however small these time intervals may be, and the distance traveled should be in a particular direction, It is like your uniform velocity. So uniform velocity, sometimes you can say that the body is in a uniform motion. If a body is in uniform velocity, we can say that the body is in a uniform motion. Okay. Then in this uniform motion, when the body is in uniform motion, what happens? Some of the important features of this uniform motion. What are the important features? The velocity in uniform motion does not depend on the choice of origin. The velocity does not depend, means in uniform motion, the body is in uniform motion, the velocity means the velocity is also uniform. The body is in uniform motion means the velocity is also uniform. The velocity does not depends upon origin. Origin means what? The frame of reference means I am observing here or I am observing there, but the body is in uniform motion. So the body is in uniform motion. So I am observing here and I say that yes, the body is in uniform motion. But if I change here at any other place and if I observe that, I will say that yes, the body is also in uniform motion. It does not depend upon the origin. Okay. Then the velocity in uniform motion does not depend upon the choice of the time interval. It does not, if the body is in uniform motion, it does not depend, means every time interval, the body covers equal displacement in a particular, equal distance in a particular direction. So if you take for 1 hour, 1 minute, if it covers 2 meter, then if you take the time interval for 1 minute, if it covers 2 meter, if you take for 2 minute time interval, if someone will take 2 minute time interval, then it should cover 4. Then 3 minute, it will cover 6 meter, like that. So it does not depend upon the interval of time. So it covers what? In 1 minute, 2 meter. So if you take for 10 minutes, 2 into 10, 20 meter it will cover. So the speed velocity is in a particular direction it covers. So the velocity is uniform. So the motion is called as a uniform motion. Okay. So that means it does not depend upon the choice of the time interval. Does not depend upon the choice of time interval. Is this? So it is the uniform motion. Okay. Then for uniform motion along a straight line, for a body in uniform motion along a straight line in the same direction, the magnitude of the displacement is equal to the actual distance traveled. If a body is in uniform motion, if the body is in a straight line in a particular direction, the body is moving in a straight line in a particular direction, the magnitude of the displacement is equal to the actual distance covered by the object, already we have discussed. Okay. Then you can note this thing also. Then the velocity is, or the motion, uniform motion is positive under what condition? If the object is moving towards the right of the origin, if the object is moving, suppose this is my origin, if the body moving towards the right of my origin, then I will say that the velocity is positive. Velocity is positive. Okay. So the velocity is positive if the object is moving towards the right of the origin, and negative if the object is moving toward the left. So if the body is moving in negative direction, so its velocity is negative. Okay. Right. For an object in uniform motion, remember this thing, no force required to maintain its motion. If it is in uniform motion, no force is required to maintain the motion, because the motion can be possible only we apply a force. If I am at rest, if force is applied, then the motion will be there. So for a body is in uniform motion, already it is in uniform motion, then no force is required. Here we can say no force is required. No force is required when the body is already in a uniform motion. Okay. Clear? So these are some of the points of your uniform motion. Then the next comes your non-uniform motion. So tell me, what is non-uniform? If the body is what? In non-uniform. If the body is means what? In non-uniform motion, a body is said to be non-uniform motion if its velocity changes. If its velocity changes with time. If its velocity changes with time, then the body is said to be non-uniform motion. Means like your variable velocity. So velocity changes with time. So means, now if you find the body is moving with 5 km per hour, then after 1 hour it is 7 km per hour, next 1 hour it is 14 km per hour. So the velocity changes in intervals of time. In 1 hour interval of time, the velocity changes. So if I observe this for a time interval, then I say that the body is in a non-uniform motion. Is that clear? So after knowing all this velocity, all these types of velocity, then we will go for the next parameter, that is called as your acceleration. Okay. So now I will go for the another one, that is another parameter or another physical quantity, that is our acceleration. So what is this acceleration? So think about an example, in that you will know that. Suppose you are with your parent, with your father or with your relatives, and you are sitting on the bike along with your guardian. Suppose you are moving in the market. So when you are moving in the market, is your velocity means the bike velocity remain uniform throughout the market? No. Suddenly you find someone is passing in front of you. Then what are you doing? You are making the velocity decreasing. You are decreasing the velocity. Suppose you find the space is open space, nobody is there, then who is riding the bike? He makes the accelerator. That is called as the accelerator. Increase the accelerator means the velocity increases. So when you are in a non-uniform velocity, then your motion is called as an accelerated motion. Your motion is an accelerated motion, and from there you are getting this acceleration. Means if you are in a non-uniform velocity, then only you will find the acceleration. So what is this acceleration? So the rate of change of velocity of an object with time, the rate of change of velocity of a body with time, with respect to time you can say, or with time is called its acceleration. Is called as a acceleration. So acceleration is equal to, I can write this acceleration is equal to change in velocity, not the velocity, it is change in velocity. Remember, change in velocity divided by time. Suppose I move with a uniform velocity. What is my change in velocity? 0. So what is my acceleration? 0. You are not in accelerated motion. So if your velocity is changing, then you are in a accelerated motion. So velocity changes means there are three parts. Either displacement changes, velocity changes, or either equal displacement, time changes, the velocity changes, or the direction changes, then also you are moving with same, but you are covering the same distance in same time, but the direction is changing, then also the velocity changes. So the change in velocity by time gives you the acceleration. Is that clear? So this is about the acceleration. Okay. So if you find this acceleration, how we will take that? Let us consider a body at time t is equal to 0. A body at time t is equal to 0. Its velocity is u. Generally u is considered as the initial velocity. At time t is equal to 0, its velocity is u. At time t means t is equal to t. At a time t, let its velocity is b. When you find that t is equal to 0, its velocity is u, that is called initial velocity, and at t is equal to t, means at a particular time interval, its velocity is v. Then what is its acceleration? The acceleration is equal to, I can write acceleration, that this can be written as a. This acceleration a is equal to change in velocity. How much the velocity changes? V minus u. In what time? T minus 0. T minus 0. So this is the acceleration of the body. So this is, you can say that the acceleration of the body. And as we know that the acceleration is a what? It is a vector quantity, because it's change in velocity. So it is a vector quantity. Vector quantity, because it depends on velocity. And if it is a vector, it may be positive, negative, or 0. It is positive, negative, or 0. We will discuss when it is positive, negative, and 0. And next is for this acceleration, unit is in SI. What is the unit? Velocity is meter per second by second. So meter per second square. It is meter per second by second, right? So meter per second square. In CGS, cm per second square. And already you know the dimension. I am not going for the dimension. Dimension means what we will write? If I write the dimension, L1 t minus 2 with a square bracket, that is the dimension. Yes. So this is about the acceleration, right? Now when this acceleration is called as a uniform acceleration, right? So the types of acceleration, we will go for the types of acceleration. different types of acceleration. One is the uniform acceleration. When the acceleration is said to be uniform, if the change in velocity is same in equal intervals of time. So next is the uniform acceleration. Uniform acceleration. When the acceleration is said to be uniform acceleration. So what we can say, the acceleration of an object is said to be uniform acceleration if its velocity changes by equal amounts in equal intervals of time. If the velocity changes equal amount in equal intervals of time. If the velocity changes in equal amounts in equal intervals of time, then the velocity the acceleration is called as the uniform acceleration. Okay, and equal intervals of time, and however small these time intervals may be, then it is called as a uniform acceleration. Means what? If you take say an example, suppose like that, in every 1 hour my velocity is increased by 2 km per hour. Right now my velocity is 5 km per hour. Next 1 hour it becomes 7 km per hour. Next 1 hour it becomes 9 km per hour. So for each 1 hour interval, how much the velocity changes? 2 km per hour. So what is my acceleration? 2 km per hour divided by 1 hour. So that is 2 km per hour square. That is the acceleration. So this type of acceleration is called uniform acceleration. Then what is a variable acceleration? Next is what is a variable acceleration? If it is not so, like your uniform acceleration, that is called as a variable acceleration. So you can say that the acceleration of an object is said to be variable acceleration if its velocity changes by unequal amounts in equal intervals of time. Velocity changes unequal amounts. Velocity changes in unequal amount in equal intervals of time. Or in other form you can say that velocity changes in equal amounts in unequal intervals of time. So that is also known as the non-uniform acceleration. This is also known as the variable acceleration or non-uniform acceleration. So if the change in velocity of the body in equal intervals of time is not same, then it is a variable acceleration or non-uniform acceleration. Is that clear? So this is the uniform and non-uniform acceleration. So now if the body is in a non-uniform acceleration, then what we will find? We will go for the average acceleration. So let me write this average acceleration. Already we discussed from speed, velocity, all these things. So the same procedure we will define one by one. Okay. So now we will go for the average acceleration. So average acceleration comes when the body is in a variable acceleration, or you can say that is a non-uniform acceleration. So average acceleration. So what is this average acceleration? The acceleration of a body is said to be the averages, or for an object moving with variable velocity, the average acceleration is defined as the ratio of the total change in velocity of the object to the total time interval taken. Okay. So that means suppose v1 and v2 are the velocity of an object. So total. So let me write change in. I will write this average velocity also. The formula I will write. Then you can write the average acceleration. A average. You can write the change in velocity divided by time interval. In what time interval the change in velocity occurs. So that is the time interval. Okay. So if the change in velocity, suppose the body has the different velocities at time t1 and t2. At t1 it is velocity is v. At t1 the velocity is v1. At t2 its velocity is v2. Then what is average acceleration? So v2 minus v1 by t2 minus t1, v2 at velocity. So we can write this is equal to delta v by delta t. So change in velocity is delta v in a time interval delta t. So I can write it the average acceleration. Okay. So this is called as your average acceleration. Then we will go for the instantaneous acceleration. How we will find this instantaneous acceleration? Next is the instantaneous acceleration. What is this instantaneous acceleration? If the body is in a non-uniform motion or non-uniform acceleration, if the body is in non-uniform acceleration, then the instantaneous acceleration is what? The velocity of an, or you can say, sorry, the acceleration is what you can say that? The instantaneous acceleration you can define as the time rate of change of the velocity. Means at a particular instant what is its acceleration. Okay. So at a particular instant what is its acceleration means what you will do? What I will write? If the small intervals of time, if you consider the interval of time is very small, then we will make this as a limit delta t tends to 0. So this is the instantaneous acceleration is equal to delta v by delta t, that equal to dv by dt with a vector symbol. So this is the instantaneous acceleration. Is that clear about the instantaneous acceleration? So after knowing this, so that means the acceleration of an object in a given instant of time. It is the acceleration of an object at a given instant of time or at a given point of its motion. Okay. Now from here we can also say that what is dv? A acceleration, a dt. Yes, this is also a formula. So if I will find the velocity at a particular instant means at a particular time interval, so I will make this as a dv, integration of dv, to know the at a particular, like that. Suppose from u and v, velocity changes from u to v. In that, what is the acceleration in this region? In this region, what is the acceleration? I will make like this a dt with time t1 to, or t1 is equal to, suppose 0, at time 0 the velocity is u, at time t the velocity is v. From here also you can calculate like this. One. Another one is that from here also you can write a is equal to, there are different forms, dv by dt. So I can write this as d by dt, v is equal to what? That is your ds, displacement I can take, ds by dt or dx by dt. So this is what? d by dt, ds by dt. So when you multiply that, you can write like this. This is double derivative. So don't make this as a d square by d square t square, right? Not like that. It will written as a d square by dt square. Means dt and dt square. It is one term. It is not d into t, dt square into s. This is also acceleration. So what is this acceleration? Acceleration can also be called as the double derivative of displacement. It is the double derivative of the displacement, and it is the first derivative of velocity. Acceleration is the first derivative of velocity or double derivative of displacement. Okay. So now we will go for the other parts like here. In this case, what is the positive acceleration, negative acceleration and zero acceleration? That is very important thing. So when this positive acceleration means, as we know, this acceleration a is equal to, for an example, let us take an example like this. Acceleration is equal to its v final velocity, initially u, in a time interval t minus 0. Okay, from 0 to t. That is already you got a relation. So then we can say that the acceleration is positive. Then we can say that the acceleration is positive. Positive acceleration. If the velocity of the body increases, then the acceleration is called as positive. Now you see here, a is positive, when a is positive, v is greater than u. initially what is its velocity, the final velocity must be greater than that, then the acceleration is a positive, isn't it? Right. So here it is a positive. So if v greater than u, acceleration is a, let me write like this, acceleration is a positive, right? If v less than u, acceleration is a, I can write short form SACL to the power n, acceleration is a negative. If v is equal to u, acceleration is 0. I will give you an example here for you. Take the example like a small child starts going for the class, So in that part, when he starts his from your home towards the school, the velocity decreases because he is not interested for the school. So in that case, here that child has a negative acceleration. But when he comes from the school to his home, he runs very fast, means his velocity increases. So acceleration is a positive. From the when it goes toward the school, velocity decreases. So he has a negative acceleration. When it goes towards home, it is a positive acceleration. Or you can say a bus starts from the bus stand, acceleration increases to reach the destination. But when it comes to the bus stand, when it reaches to the bus stand, when it reaches at that destination, then its acceleration negative, decreases. So okay. So this is the acceleration, not the velocity decreases, so acceleration is a negative. So this is the meanings of this positive, negative and zero acceleration. And other things like you can discuss here. If in this case acceleration of a body is positive, if the direction of acceleration is the direction of the motion of the body. Acceleration is positive means if the direction of motion of the body is along the direction of acceleration. Direction of acceleration is along the direction of motion. Means acceleration. Think that acceleration means someone is pushing you, accelerating. I am accelerating you. The bike is accelerating, right? So when the acceleration is negative, that negative acceleration is called as the deceleration, retardation. This negative acceleration is called as the retardation. This negative acceleration is also called as the retardation or deceleration. Deceleration. Negative acceleration is called deceleration. Okay. Then acceleration of a body is negative if the direction of acceleration is in the direction opposite to its motion. The direction of acceleration is opposite to the direction of its motion. Means someone is pulling you. Means my acceleration is negative means my velocity is decreasing. So decreasing means I am not interested to go in the direction of motion. In what direction I am going? My motion direction. In that direction I am not moving. I am not interested to move. So my acceleration is decreasing. So negative acceleration. Okay. Then not acceleration is not decreasing, velocity is decreasing. Okay. Then when velocity and acceleration are of an object are in the same direction, then what happens? If your velocity and acceleration are in the same direction, then what happens? The speed of the body increases. Means you are on the motorbike, you are accelerating, means your speed is increasing, and you are accelerating, raising means accelerating. Okay. Then your velocity increases, so speed increases. Next, in that when velocity and acceleration of an object are in opposite direction, you want to go along this direction, your velocity is along this direction, but you are decreasing the bike, the accelerator, you are slow down, then your velocity decreasing, your velocity is decreasing, so the speed of the object decreases. Okay. An object speeds up even if its acceleration and velocity are negative. When both are negative also, the acceleration and velocity are negative, the body can speed up, means velocity increases, negative and negative. So the body speeds up, means in opposite direction. It speeds up in a opposite direction. Okay. Then acceleration of an object is zero if its velocity is always constant. But in this whole discussion, we will deal only with the uniform acceleration. We will discuss the equations of kinematics in the next classes. There we always consider the acceleration is uniform. So you go in detail about the uniform acceleration. Okay students, go through this video and any doubts then you can ask. Okay, thank you.